Introduction to Trigonometry. We will start with trigonometric ratios. We shall proceed to trigonometric ratios of some specific angles. We shall elaborate on trigonometric ratios of complementary angles. And finally, in this chapter, we shall derive the trigonometric identities. Let us start with trigonometry. The word trigonometry is derived from the Greek words trigonometron, means three sides measure. In our previous classes, we have studied about triangles and in particular right triangles. In right triangles, the distance or the height can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. Basically, trigonometry is the study of relationship between the sides and the angles of a triangle. Early astronomers used it to find out the distance of stars and planets from the Earth. Even today, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometric concepts. So let us study them in detail. We start with trigonometric ratios. Consider a right triangle ABC. Here we can see that angle CAB, or in short angle A, is an acute angle. Now note the position of side BC with respect to angle A. We can see that it faces angle A, so we can call it side opposite to angle A. We know that AC is called the hypotenuse of a right triangle since it is side opposite to the right angle, and the side AB is a part of angle A, so we call it side adjacent to angle A. Now suppose instead of considering angle A, we consider the other acute angle, that is angle C. Then we notice that the position of the sides changes. AB becomes the side opposite to angle C, while BC becomes side adjacent to angle C. Now we are in a position to define certain ratios involving the sides of right triangle and call them trigonometric ratios. We define the trigonometric ratios of angle A in a right triangle ABC as, first one is sine of angle A equal to side opposite to angle A by the hypotenuse, which is equal to BC by AC. Next ratio is cos of angle A. It is defined as side adjacent to angle A by the hypotenuse, that is equal to AB by AC. Third ratio is tan of angle A, which is defined as side opposite to angle A by side adjacent to angle A, that is BC by AB. Corresponding to these three ratios, we have the reciprocal ratios with different names. Reciprocal of sine of angle A is cosecant of angle A, so it can be written as 1 by sine of angle A. So this will be hypotenuse by side opposite to angle A, that is AC by BC. Reciprocal of cos of angle A is secant of angle A, that is secant of angle A is 1 by cos of angle A. So in terms of ratio, it will be hypotenuse by side adjacent to angle A, that is it will be equal to AC by AB. And the reciprocal of tan of angle A is cot of angle A, which is equal to 1 by tan of angle A. In terms of ratio, it will be side adjacent to angle A by side opposite to angle A, which is AB by BC. The ratios defined here can be written as sine A, cos A, tan A, cosecant can be written as cosec A, secant A can be written as sec A, and cot A can be written as cot A. Also, we can note that tan A is BC by AB, which can also be written as BC by AC whole by AB by AC, that is tan A is equal to sine A by cos A, and which would imply that cot A, which is the reciprocal of tan A, is also equal to cos A by sine A. So here we see that the trigonometric ratios of an acute angle in a right triangle expresses the relationship between the angle and the length of its sides. We have defined 6 trigonometric ratios of an acute angle. If we know any one of the ratios, can we find the other ratios? Let us see how we can do it. Consider a right triangle ABC and say we are given one of the ratios sine A equal to 1 by 3. But we know that sine A equal to opposite side by hypotenuse, which is equal to BC by AC. This implies that we are given the ratio BC by AC equal to 1 by 3. So, if BC is K, then AC will be 3 times K. Note that K is any positive number. Now, to find the other ratios, we need the length of the third side. So we can use Pythagoras Theorem and find AB. We know that by Pythagoras Theorem, AC square equal to AB square plus BC square. We substitute the values of AC and BC and find the value of AB square equal to 3k whole square minus k square, which is equal to 9k square minus k square equal to 8k square. Then AB equal to under root of 8k square, which gives us AB equal to 2 root 2 times k. Since we have the value of AB now, we can calculate all the other ratios. We know that cos A equal to adjacent side by hypotenuse, which is equal to AB by AC, which is equal to 2 root 2 times k whole by 3 times k, and we get two root 2 by 3. Now we can calculate tan A, which is given by Sine A by cos A, which is 1 by 3 by 2 root 2 whole by 3, that is tan A equal to 1 by 2 root 2. Once we have Sine A, cos A and tan A, it is easy to find their reciprocals. Cosec A is equal to 3 by 1, which is the reciprocal of Sine A. Sec A will be reciprocal of cos A, so the value is 3 by 2 root 2, and cot A is reciprocal of tan A, so the value will be 2 root 2 by 1. Also notice that since hypotenuse is the longest side in a right triangle, the value of Sine A and cos A is always less than, or in particular in some cases it is equal to 1. Let us read the question. Given tan A equal to 4 by 3, find the other trigonometric ratios of the angle A. We are given tan A, which is equal to opposite side by adjacent side. So we have BC equal to 4k, then AB equal to 3k. So let us use Pythagoras Theorem and find the side AC. We have AC square equal to AB square plus BC square. On substituting the values, we get AC square equal to 25k square, that is AC is equal to 5k. Now it remains to find Sine A, which is opposite side by hypotenuse, that is 4k by 5k equal to 4 by 5. Cos A is adjacent side by hypotenuse, so cos A is 3 by 5. Now it remains to find the reciprocal ratios. We have cosec A equal to 1 by sin A, so cosec A is 5 by 4. Sec A equal to 1 by cos A, so it is 5 by 3. and cot A is equal to 1 by tan A equal to 3 by 4. Ultimately, we have found out all the other trigonometric ratios when tan A was given to us. Let us read the question. If angle B and angle Q are acute angles such that sine B equal to sine Q, then prove that angle B equal to angle Q. For the proof, let us consider two right triangles ABC and PQR. We are given sine B equal to sine Q. So firstly, we have sine B equal to AC by AB, while sine Q equal to PR by PQ. Since sine B equal to sine Q, AC by AB equal to PR by PQ, this would mean AC by PR equal to AB by PQ equal to, say, K. That means two corresponding sides of triangle ABC and triangle PQR are in ratio. If we can prove that the third side is also in ratio equal to the other two ratios, then the triangles will be similar. So let us find out BC and QR. By Pythagoras Theorem, we have BC equal to under root of AB square minus AC square and QR equal to under root of PQ square minus PR square. Now let us take the ratio BC by QR. Substitute the values. Here we can see that AB can be written as K times PQ. So this is equal to under root of K square PQ square. Similarly, AC can be written as K times PR. So we have K square PR square whole by under root of PQ square minus PR square. On solving further, we get the following expression, and ultimately the ratio becomes equal to K, implying that BC by QR is also equal to K, that is, all the three sides of triangle ABC and corresponding sides of PQR have the same ratio, that is, triangle ACB is similar to triangle PRQ, and this implies that angle B equal to angle Q. Hence we have proved the required result. Let us read the question. Consider triangle ACB right angled at C, in which AB equal to 29 units, BC equal to 21 units, angle ABC is theta. Then determine the values of cos square theta plus sin square theta and cos square theta minus sin square theta. So let us start by finding sin theta and cos theta first. Using Pythagoras theorem, we know that AC equal to under root of AB square minus BC square. Substitute the values. We have 29 whole square minus 21 whole square under root. This will give us under root of 400, that is 20 units. So AC is 20 units. Then sin theta is how much? Sin theta will be AC by AB equal to 20 by 29, while cos theta will be BC by AB equal to 21 by 29. Simply substitute the values in the first expression. Cos square theta plus sin square theta will be 21 by 29 whole square plus 20 by 29 whole square. This will give us 29 whole square as LCM and numerator is 21 square plus 20 square, which is equal to 400 plus 441 whole by 841, which is equal to 1. Similarly, we can calculate the second part. We have cos square theta minus sin square theta. This will give us 29 whole square, 21 whole square minus 20 whole square, which will be equal to 441 minus 400 whole by 841, that is 41 by 841. Let us read the question. In triangle OPQ, right angled at P, OP equal to 7 centimeters, OQ minus PQ equal to 1 centimeter. Determine the value of sin Q and cos Q. In triangle OPQ, use Pythagoras theorem. We have OQ square equal to OP square plus PQ square. Since it is given that OQ minus OP is 1, this implies that OQ equal to 1 plus PQ. So substitute here, we get 1 plus PQ whole square equal to OP square plus PQ square. Solving this further, use the formula for A plus B whole square, expand. Now PQ square and PQ square gets cancelled. We are left with 1 plus 2PQ equal to OP square. We have OP equal to 7 and 1 plus 2PQ. From here we can find the value of PQ, which will be 49 minus 1 whole by 2, that is 48 by 2 equal to 24 centimeters, and substituting in OQ minus PQ equal to 1, we get OQ equal to 1 plus 24 equal to 25 centimeters. Now simply we can find Sine Q equal to 7 by 25 and Cos Q will be 24 by 25.